Alright, the next topic that we're going to look at is representing data using pie charts, line graphs, and bar graphs. So there are lots of different ways to represent data. Three that we're going to look at in this section include a pie chart or a circle graph, a bar graph, and a line graph. Now right now we are in the midst of the coronavirus pandemic and we are doing social isolation. So with that, on the news, if you're watching the news, you will see all sorts of charts and line graphs and data representation. And so let's go ahead and kind of look at three to see the difference. A pie chart or a circle graph shows how a total amount is divided into parts. There are two different ways you can represent the data. You can label each section with the actual amount, or you can label each section with its percentage of the total. So for instance, over here, we have a circle graph, and it says the total number of FDA registered facilities is 1788. Inside that pie graph, or pie chart, we have the breakdown. For instance, the U.S. has the highest percentage of FDA registered facilities. It has the largest pie piece. Canada has the smallest in terms of what we're given here. It is represented by the smallest piece. To figure out how many of the facilities are in these different regions, you will need to take a percentage of the total. Another one that you see on the news quite often right now is bar graphs. Bar graphs are used to represent data for making comparisons. It can either be a single or a double bar graph. So for instance, we have one down here. It says that the elderly are most at risk for the coronavirus. Each one of these, note that we have 10 to 19-year-olds is 0.2%, 20 to 29-year-olds is 0.2%. And we go down further and further, and we can see that as the age increases, the percentage also increases. The third one that we're going to look at is something called a line graph. And line graphs are used to represent trends over time. This is the most common one that we see right now with our coronavirus, is what's happening on a daily basis. So you can either have a single or a double line graph, but with everything that's going on right now, they are extending this to include many lines at the same time. For instance, if we look at this last one, we can see that each one of these lines is represented by a different state, and we can see exactly what's happening as the coronavirus goes from day 1 to, who knows when this is ever going to end. Okay, so now that we've seen some examples of this in terms of coronavirus, let's see what we can do with this data. We're going to go into some stuff that's a little bit more enjoyable to talk about. Okay, so let's start with circle graphs. The circle graph indicated here shows you how the 24 hours in the life of a college student are divided among different activities. And of course, this is going to be without coronavirus. So, the greatest number of hours is spent in which activity? We want to know which pie piece is largest. And the largest pie piece is sleeping. I don't know about you, but right now I sleep quite a bit. More than usual. All right. B, we want to know how many more hours are spent working than studying. So working, we spend 6 hours. Studying, on average, we spend about 4 hours. And to figure out how many more hours are spent working than studying, we are going to subtract. So we get 2 hours. Okay, for C, we want to find the ratio of hours spent driving to the whole day. So remember, ratio is a fraction. Our numerator is going to be the amount spent driving, which is 2, over how many hours in a whole day. We're told that the whole day is 24 hours long, which hopefully you knew that. We can simplify this fraction, and we get 1/12 of our day is spent driving. Okay, what about the hours spent studying to the hours spent working? So the hours spent studying will be my numerator. We have 4 hours, over the hours spent working. We have 6 hours. And we can go ahead and simplify this. We get a ratio of 2 to 3. All right, so this is our first circle graph. Notice that each pie tells us how many total hours we spent. This is not the percentage one, so now let's go ahead and look at a percentage one. Okay, so we have the yearly vending machine snack food sales in the US was $36 billion. The circle graph shows how sales were divided among various types of snack foods. So notice that each one of these pieces has a percentage next to it. So we want to find the amount spent on candy. To figure that out, we are going to do 32.5, actually 0.325. I'm going to use the percent equation, times 36. If we multiply this, I get 11.7 billion dollars. Okay, let's try potato chips. Potato chips is 13%. I want to convert that to a decimal. So I'm going to make this 0.13. Remember, we move our decimal place 2 places to the left. We're going to multiply this times our total. And we get 4.68 billion dollars. And the last one, we want to know the amount spent on corn chips and nuts. So we can do this one of 2 ways. We can calculate how much is spent on corn chips and how much is spent on nuts, and then add the 2, or we can start by adding our percentages. I'm going to go ahead and add my percentages, that way I only have to multiply 1 time. So if we add 5.1 plus 5.9, we get 11% is spent on corn chips and nuts. So if we now go ahead and multiply our 11% as a decimal, which is 0.11, times our total, 36, we get 3.96 billion dollars is spent on corn chips and nuts. All right, those are our circle graphs. So let's go ahead and look at some bar graphs. So, as I said, you can have a single bar graph or you can have a double bar graph. Those are the most common you will see in your math classes. So we have the graph below shows the number of new eFlix subscribers for each quarter for 2 different years. The pink line is going to be the year 2016, and the green bars are going to be the year 2017. We want to find the number of eFlix subscribers in the second quarter of 2017. So we're going to look at the second quarter and we're going to look at the green bar. So if we come here, we are at 400, and we also need to pay attention to what it says here, that this is new subscribers in thousands. So this is going to be 400,000. Okay, B, we have in what year and quarter was the greatest number of new eFlix subscribers. So our highest point is right here. We are in the fourth quarter. It's a green bar, so it's going to be the fourth quarter of 2017. C, we have by how much did the number of eFlix subscribers decrease between the second and third quarters of 2016. So we are looking at second and third, and we are looking at the pink bars. So we get for 2016, we have it was 600 minus the third quarter, we have 400, and we get 200, and now I'm going to go ahead and add on my thousands. Okay, so that takes care of our bar graphs and different things that we can do with bar graphs. Let's go ahead and now look at a line graph. So again, we can have a single line graph or we can have multiple line graphs at the same time. For this one, we are comparing the sales of laptop computers and desktop computers. So we want to determine the number of desktop computers sold in 2014. I'm going to assume that the blue line is my desktop computers, and I'm going to assume that the red line is my laptop computers. So, desktop computers in 2014, we're looking at our blue line, and we want to find 2014. We're going to be right here. So we have 40. This is in thousands, so this is going to be 40,000. Okay, determine the number of laptop computers sold in 2013. So 2013, we are looking at 2013. We are looking at the red line, our laptop computers, and we get 20,000. Part C, what was the first full year in which the number of laptops sold was greater than the number of desktop computers sold? So when is the red line above the blue line? So as we go across, we have our blue line is above our red, and it's not until right here that we get our red line is above our blue line. So this is going to be 2015. And part D, what was the amount of the increase and percent of increase in laptop sales from 2013 to 2014. So let's find the amount of the increase from 2013 to 2014 for our laptop computers. So we are looking at a 20 to 30. This is an increase of 10. We do 30 minus 20 to get our 10,000. To calculate the percent of increase, I'm going to use my percent proportion. I'm going to put my amount of the increase over the original amount, which was 20. If we cross multiply, we get 20p equals 1,000. And if we divide by 20, we get p equals 50%. All right, that goes ahead and takes care of analyzing different ways to represent data. Couple more sections. I think we've got 1 or 2 left, and then that will be the end of the semester.